Okay, guys, we are going to factor. You have done this before, so hopefully this makes sense. So a quick reminder, factoring is when you find factors of negative 18. So if I write them down for you, factors of negative 18, be like 1 times 18, 2 times 9, and so on and so forth, 3 times 6. And you find the factors of 18 that add to 7. So this is negative 18. I'm going to choose 2 and 9. I'm going to say x minus 2 and x plus 9. So this is how I factor. And just like yesterday I gave you the zeros and asked for the factors. If I ask you for the zeros, you set each of these equal to 0 and solve. So if x minus 2 would be 0, one of my zeros would be 2, and the other one would be negative 9. So these are your zeros, okay? This is your factors. Okay, so similar, I'm going to move to the right. X squared minus 14x plus 49. You are going to find factors of 49 that add to negative 14. So if you have a plus and a minus here, they are both going to be negative. Okay, because negative 7 times negative 7 is positive 49. If I set them equal to 0, the only factor I have is the factor x equals 7. So if I drew a picture of this one, it would touch over here in one spot right here at positive 7. Other things you need to do when factoring, you sometimes have to factor out a greatest common factor. So I can factor a negative 3 and an x squared out of both of these terms. So I'm left with x here and plus 4 here. Sorry, that should be a minus 4, so I'm going to erase it. So when I factor out a negative, I get a minus. This factor gives me x equals positive 4. And this one gives me x equals 0. Technically, it happens twice because I have x squared. So it would give me a 0, like 0, 0, and 4. But you just have to do this. If I drew this picture out of 0 and 4, it would look probably something like this. Okay, when I just say sketch a picture, it doesn't have to be perfect, but like a basic sketch gives you somewhere close to what it should be. Similar on this one, I'm going to factor out a 3 first and an x. I'm going to erase that. So always look for a greatest common factor. Okay, when I do that, I am left with x squared here and 16 here. This one gives me x equals 0. Okay, and then this one, I can actually factor one more time. It's the product of perfect squares. So then I also get x equals plus or minus 4. I was going to talk about the product of perfect squares with this last one here, but I just kind of did. When you have a perfect square here and a perfect square here, you always get x plus the square root of 36 and x minus the square root of 36, whatever it is. If you FOILed this back out, the middle terms would drop out. Basically, there are factors of 36 that add to 0 and multiply to negative 36. So that's where I get the 6 and the 6. When we are doing the AC or the grouping method, things get a little bit trickier. So make sure you pause a lot and ask some questions. So when we're talking about this in standard form here, for example, like this is A, this is B, and this is C. So the AC method tells you to multiply A times C. So I'm going to take 4 times negative 5. Oh yeah, and this is when the leading coefficient, let's write that down, does not equal 1. Okay, so like in this case, it equals 4. So I get negative 20. I now need to find factors of negative 20 that add to positive 1. That's B. So hopefully you see that here. So I'm going to choose negative 4 and positive 5 because that would give me positive 1. So now I'm going to rewrite this middle term here. I'm going to rewrite it as negative 4x and positive 5x. So that was just the middle term. Hopefully you see that if I combined these two, if I combine them, I'd be back at positive 1x. These others, I'm just going to copy back down in pink. Nothing has changed. Okay, so I copied down A and C. The only thing that I changed was I split open B into two pieces. Okay, now I'm going to draw a line straight down the middle. And I'm going to factor out of the first half a 4 and an x. When I do that, I'm left with x minus 1. And similarly over here, I'm going to factor out a positive 5, excuse me. And when I do that, I'm left with x minus 1. You know that you've done this correctly when both of these equal each other. Okay, one factor then, one of our factors is what's left, which I'm going to underline in pink. One factor is 4x plus 5. And the other factor, which I'm going to give in blue, is x minus 1, and that comes from here. Okay, these are your two factors. When you are trying to solve for the zeros, this is the easy one, x equals 1. Okay, this one over here is not quite so easy. You actually have to say 4x plus 5 equals 0. Remember, set it equal to 0 and solve. And divide. X equals negative 5/4 is going to be one of them, and x equals 1 will be the other one. Those are your two zeros for this one. Okay, I'm going to do AC method one more time. I'm going to kind of move this over so that I have more room to write. Okay, so the first thing that I'm going to do is take A times C. So A is 3, C is negative 2. So 3 times negative 2 is negative 6. And I need factors of negative 6 that add to positive 5. Okay, because this is B here, positive 5. So I'm going to say plus 6 and minus 1. Okay, so now I'm going to only rewrite part B as 6x minus 1x. Okay, that's all I'm going to do is rewrite it. And then these others are going to come back down. 3x squared, and there was a plus there. There was a minus 2 here. Okay, so now I'm going to draw a line down the middle. My middle line is going to be right here. And out of this side, I can factor a 3 and an x. And I'm left with x plus 2. My stylus isn't working. X plus 2. Over here, I'm going to factor out a negative 1, because then that leaves me with x plus 2. And that's good, because again, I want these two things to match. Okay, so over here, I'm going to write my two factors. One factor is 3x minus 1, and then the other one is x plus 2. When I write my zeros, this one gives me x equals negative 2. This one you might have to show your work. Okay, x equals 1/3. So these are my two zeros that came from my AC method of factoring. The last one is actually not it's not an AC method, but I just want you to be aware of that sometimes you're going to get like product of perfect squares here, and you're going to want to just be able to recognize that this is a perfect square here and this is a perfect square here. So just like we did yesterday, what's going to go here is not 25, but like the square root of 25. So this will be 5x minus 3 times 5x plus 3. Okay, so these are perfect squares. And you could double check by multiplying them out again, but beware of the product, or I'm sorry, the difference of squares, difference of perfect squares. So that's what this is called. And that's because 25 is a perfect square, x squared is a perfect square, and 9 is a perfect square.